Okay, in the first section we talked about our graphing of sine and cosine functions, and we looked at two of the variables that we have here. A is the amplitude, B being the period length. Once again, just a quick definition. A is how high and low the graph goes on the y-axis in both the sine and the cosine curves. B affects the period length. That equation we had was period length equals 2 pi divided by B. The larger B is, the smaller the period length. The smaller the B is, the larger the period length. Today we're going to move on and look at two other variables that will affect the curves themselves. C is shifting the graph to the right or the left along the x-axis, so it moves all of our critical points, the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. It moves them left to right on the y-axis, and that's the same case in both sine and cosine. And then K is a value that shifts the entire graph up and down along the y-axis. Notice that K is a constant. It's outside the actual function of sine or cosine itself. These other values, A is being multiplied by sine, A is being multiplied by cosine, B and C are inside the parentheses, so they're part of finding the sine of the angle or the cosine of the angle. They're part of the argument. K is a constant, so it moves the entire graph either up or down on the y-axis. That's what described here. C shifts the graph right or left. B also has an effect on that because the period length has changed. Same process. We did that back in that first section. In order to graph these, that argument now contains the C value, so it's bx plus C. We set that equal to our corresponding critical points. We solve for x. We discovered through our work that if we find the starting, quarter, and mid points, that should be enough information to get the other two or any other subsequent points on either side because they have equal spacing. Amplitude here, changing the amplitude to negative creates that reflection. We saw one of those graphs back in our first section, and K is our vertical translation that shifts the entire graph up or down. And if I'm not mistaken, we're going to jump right into some graphing here. Our first one says the graph y equals cosine of 2x minus pi over 3. Now, just as we learned from the first section, 2x minus pi over 3 is our argument. So that part hasn't changed. We still set it equal to 0. All of our first graphs started at 0. These are not, because we're going to have some algebra work to do here. So we're going to add pi over 3 to both sides. That would get me 2x equals pi over 3. I'll divide by 2, which is multiplying by 1/2. Let's get rid of that so it doesn't look like a negative sign, maybe. Okay, so ultimately our starting point is going to be pi over 6. So notice our starting point is no longer 0. We moved that graph over. It now starts at pi over 6. And repeat the process for the quarter point. So 2x minus pi over 3. If you recall, our quarter point is at pi over 2. I'm going to add pi over 3 to both sides. Noting here we have some fraction work to do. So 2x equals, in order to add fractions, we need a common denominator. My common denominator would be 6. This would change to 3 pi over 6, and this would change to 2 pi over 6. So 2x equals 5 pi over 6. When I add those two fractions together, I'll divide by 2, which is multiplying by 1/2, and x equals 5 pi over 12 for our quarter point. And we'll go one more time here. 2x minus pi over 3. We'll find our midpoint just to verify our algebra skills here. We'll add pi over 3. 2x now equals 4 pi over 3. We'll divide by 2, which is multiplying by 1/2. Here I'll cross cancel a 2 and the 4 to be a 2 and a 1. So my midpoint is at 2 pi over 3. I'm going to rewrite these terms down here with a common denominator, looking at what we have. We have a 6, a 12, and a 3, so my common denominator would be 12 for all of those. So my starting point is at 2 pi over 12. 5 pi over 12 will stay, and then 2 pi over 3 will become 8 pi over 12. If I have all three of those, it should be pretty easy to see that we're going to add 3 as our spacing is supposed to be the same all the way through. So I have 11 pi over 12, 14 pi over 12. Let me just take a backtrack here. Looks like we're just going to graph one period, so I'll just go with those 5 critical points for right now. Sketching that graph in here. Arrow back up again to see what our amplitude was. Our amplitude is an unwritten 1 right here. So we'll go up to 1 and down to -1 on our y-axis. 1 and -1. We are oops, let's go ahead and put those values on there as well. 2 pi over 12. Again, simplify those down as you put them back on here. It's 5 pi over 6, then 5 pi over 12. 8 pi over 12 is 2 pi over 3. 11 pi over 12 doesn't simplify. And one more critical point here. 14 pi over 12 is 7 pi over 6. We are graphing cosine here, so hopefully by now we all know what cosine looks like. Cosine starts up, our highest point, comes down through minimum, back up, and back up. Looks like I have an extra, oops, no I don't, I need to backtrack. I got all sorts of goofy stuff going on here. Let me get rid of those critical points. This is the one mistake I would warn you against making, and I made it myself. Pi over 6, 5 pi over 12. Notice that the graph starts at pi over 6. Our graph starts over here, comes down to the x-axis, and comes back up. And there, our graph has essentially been shifted over to the right by pi over 6 on the x-axis. So that's what the effect C has on the graph. We'll go ahead and go through that one more time here with our next graph. Y equals 1/2 times the sine of 1/2 x minus pi over 6. Our argument is right here, 1/2 x minus pi over 6. Start out to find our starting point, something equal to 0. 1/2 x equals pi over 6. I'll multiply both sides by 2, and x will equal pi over 3 for our starting point. Repeat the process for our quarter point, 1/2 x minus pi over 6. That now equals our quarter point of pi over 2. I'll add pi over 6. 1/2 x. Have to have a common denominator. Add those two. The common denominator is going to be 6, so this would be 3 pi over 6. I'll add those to get 4 pi over 6 and simplify those mentally to be 2 pi over 3. Multiply both sides by 2, and x equals 4 pi over 3 for my quarter point. Oh, goodness. And one more time, 1/2 x minus pi over 6, excuse me, equals pi for our midpoint. We'll add pi over 6, and 1/2 x will equal 7 pi over 6. Multiply by 2, and x will equal 7 pi over 3 for our midpoint. These are much easier because they all have the same denominator of 3. So pi over 3, 4 pi over 3, 7 pi over 3 should be fairly obvious. We're adding 3, so our next two critical points are at 10 pi over 3 and 13 pi over 3. We'll go ahead and graph here. It says to graph, doesn't say how many periods, so we'll just graph one period. But our amplitude was 1/2, so I'm going to mark 1/2 and -1/2 here on our y-axis. Pi over 3, 4 pi over 3, 7 pi over 3, 10 pi over 3, and 13 pi over 3 as our x values. And simply noting, I'll backtrack up the line here a little bit, we're graphing sine. Sine starts down here, goes up, comes back down through, and follows that pattern. So our sine curve for one period is going to look something like that. Let's continue on here. We have 3 problems that say to find the amplitude, period length, phase shift. Phase shift is something that's new, -c divided by b. We've identified our A, B, C value, so that shouldn't be anything new. And our vertical translation, that is the K. So here's our A, here's our B. Phase shift is negative C divided by B, and K is our vertical translation, moving it up or down. So we look here. Amplitude can be picked out very easily by visual inspection. Our amplitude is 3. Fairly simple. Period length, we've worked with that formula before, 2 pi divided by B. We should be able to identify B from this equation, 2 pi divided by 1/2, or 2 pi times 2 over 1. So our period length is 4 pi. The phase shift is new. I'll rewrite it down as negative C divided by B. So I have negative. Coming up here, C is negative pi over 8, and B is 1/2. So simplifying here, a negative negative give me a pi over 8. I'm dividing with fractions, so I multiply by 2 over 1, and my phase shift is pi over 4. That phase shift could actually be used to shift the starting point. So this graph, we could move from 0 over to starting at pi over 4, but honestly that's all about what we can use it for right now. And then K is simply our vertical translation. Noticing up here there's no constant being added or subtracted here in front, so there is no vertical translation in this equation. Okay, so that's the A, B, C, and K. We'll go through this a second time. Y equals negative 2 times the sine of 3x plus pi over 4. So our amplitude, visual inspection, negative 2. Period length, 2 pi divided by B, 2 pi divided by 3. No more simplification to do. Phase shift, negative C divided by B, which in this case is negative pi over 4 divided by 3, or negative pi over 4 times 1 over 3. So our phase shift is negative pi over 12. So this one's going to be shifted to the left by pi over 12. So we're going to start over on the left-hand side of the y-axis. And our vertical translation is our K value, and there is no K value being added or subtracted up here, so once again, it's not applicable in A. And one last time here, let's go with our third problem. We have our amplitude. Now make sure we pick out the amplitude correctly. Amplitude is a number being multiplied by our function, so 2 is being multiplied by our function. That's our amplitude. That's how high and low we're going to go on the
Would you please report to the office?
y-axis. Period length, 2 pi divided by B. In this case, 2 pi divided by 1/3. 2 pi times 3 over 1, or 6 pi is our period length. Phase shift, negative C divided by B. Negative 2 pi over 3 divided by 1/3. The back-to-back negative signs are going to be positive, so I have 2 pi over 3 multiplied by 3 over 1. So our phase shift is 2 pi, because the 3's will cancel. And our vertical translation, again, is that K value. This time we do have a K, so we're going to shift that up by 3 units. That's what our vertical translation would look like. And that covers those types of problems. And I think we'll end by adding or by graphing 2 problems that have a vertical translation. So what I would suggest we do here is we start out and we'll just ignore the 2 for right now. We're going to graph 3 times the cosine of x. Now the good news is I don't have a B or a C value here, so there's no change in the period length. There's no change in the shifting left or right. So my critical points are 0, pi over 2, pi, 3 pi over 2, and 2 pi for the first period. And I'll just keep going here with 5 pi over 2 and 3 pi and 7 pi over 2 and 4 pi, since we're going to graph 2 periods. Okay, so then let's sketch my x and y axis here. Our amplitude is 3, so I go up to 3. I go down to negative 3, and I'll put pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi on here to get our 2 periods worth. I'm going to go ahead and plot those points. It's a cosine curve, so cosine starts up here, comes down, all the way down, back up, and so forth. Follows those points, or that pattern, all the way through. Now, we could go ahead and connect those. I'm not going to. I'm going to illustrate. Now I'm going to bring that vertical translation back into play. So notice it's a positive 2. So I'm going to put 2 more tick marks up here to go at 4 and 5. And all I'm going to do is take the critical points that I have here and shift each of those up 2 units. So instead of being at 3, I'll be at 5. Instead of being at 0, I'll be at 2. Instead of being at negative 3, I'll be at negative 1. And so forth. So we can just move our entire set of points up by 2 units. And those are the points that we will plot to come up with our actual graph. And again, there's no real need to connect the blue ones, but if we did, keeping in mind that mine's just a sketch, but the more accurate we are, the more you'll see that those two are going to be parallel. Every single point has been shifted up 2 units. But red is the actual one we're looking at. Red is the y equals 2 plus 3 times the cosine of x. Okay, so we shift that entire graph up 2 units. We'll go one more time here. I'm going to apply the same idea. I'm going to ignore the 3 for right now and graph negative 2 times the sine of x plus pi over 3. Unfortunately, here we have some legwork to do, so I take the x plus pi over 3, set it equal to 0 to find our starting point. I'll subtract pi over 3 from both sides, so this graph will start at negative pi over 3. I'll repeat the process. Let's say our argument is x plus pi over 3. We want to find our quarter point, so I'll set equal to pi over 2. Subtract pi over 3 from both sides. We need a common denominator here, so it's 6. That gets me 2 pi over 6 and 3 pi over 6. We're subtracting, so x equals pi over 6 for my quarter point. And we'll go a third time just to make sure we haven't made a mistake with our math or our algebra here. So x plus pi over 3 is going to equal pi, which is where our midpoint is at. I'll subtract pi over 3 from both sides, and x equals 2 pi over 3 for our midpoint. Oh, we have 2 different denominators here, pi over 3, pi over 6, and 2 pi over 3. So we'll go ahead and write those all denominator of 6. So this negative pi over 3 is now negative 2 pi over 6, pi over 6, and 4 pi over 6. When we have them written that way, we should be able to see that the same distance apart is adding 3 to our numerator, so 7, 10, 13, 16, and I think 19. Do I need one more? 1, 2, 3, 4, 5, 6, 7, 8. I need one more, 22 pi over 6. So those are my critical points for 2 periods. Noting that we are going to have one point here on the left of the x-axis, so I have negative pi over 3, like left of the y-axis, sorry, pi over 6, 2 pi over 3, 7 pi over 6, 10 pi over 6 is 5 pi over 3, 13 pi over 6, 16 pi over 6 is 8 pi over 3, 19 pi over 6, and 11 pi over 3. When I simplify that, what else do we have here? We have an amplitude of negative 2, so I go up to 2 and down to negative 2. Now, because we have that negative amplitude, we will start and go the opposite direction. If I'm not mistaken, this was also a sine curve. It was. So sine will still start here, but instead of going up initially, it will go down and back up, and we'll just have that reflection to graph our points here. And now I'm going to have to arrow back up or scroll back up, and going back and forth, I'm going to uncover our vertical translation, which is up 3. So on my graph, I'm going to move each point up 3 units. So 3, 4, 5. And now instead of being at 0, we're going to be up 3. Instead of being at 2, or -2, we're going to be a positive 1, up to 3, up to 5, and we'll just follow our pattern as we move from right to left, or left to right. And once again, trying to connect those points. I know I missed that first one by a little bit, but you get the general idea. That red line is our actual graph of 2 periods with our vertical translation. And that covers our next section.